Hello, I wanted to share with you how did I made charts for aviation with interactive readouts directly on graph. How to read such charts if all you have for start is only some graph. Whatever it is scanned or directly copied from your airplane manual. Those graph are interactive. It means that whenever you change any of given value, it will follow the line and read out rest of values. It will also visualize it, so you will be able to check that algorithm by your own. We are starting with acquiring data from image. I assume that you have already copy of that image on your computer. The best solution to acquire such data is free WebPlotDigitizer. Here I have already started with calibrating image. If you know dimensions you can skip that part, but I was lazy and I wanted to use that tool also to acquire such data. So I did calibrated only 10 mm of square in left corner, to later read out whole dimensions. Such calibration is necessary if you want later to understand values which are given here. I will read out and everything in millimeters on X and Y axes. Maximum on X-axis is for me what I see in left column, and Y-axis is on right column. Now recalibrate it with maximum values. Remember that you don't have to be super accurate. It enough that millimeter error. With that WebPlotDigitizer, I help myself with arrows after clicking. Next step is to read out borders of image. If you click in every corner and move out point with arrows so it will not be visible, you will easily find border of picture. Those values are necessary for us for later calibration graph in Excel, as we will load the same picture. Now let's follow the example and gets its values for start. Notice that I double point resolve point. Later on Excel it will draw a line from that points I just clicked. Next very useful tool is Plotly. I use it for visualize what I just got, and also export data via clipboard into Excel. But unfortunately I had some regional issues VIRD has to be exchanged into comma. So I had to remember that Excel likes commas while online software prefers dots. Now on Excel, we can make chart from such data. Values are a little bit too accurate, so we will fix it later. Resize area of chart to take full size, remove unnecessary axes and subaxes. Add image background. And before removing axes, we need to set scale on them. Scale will be maximum and minimum values from data extracted as borders. If everything is calibrated well, then we will have such chart where example is covered by line. The next step is to understand what kind of data you have and how to align it. So you can freely change some values and see what happens. Here I remove unnecessary accuracy, and I'm trying to figure out which values are given from beginning and which one have to be resolved from chart. I remove connection to borders as it was only helper for us to draw a line. Excel will interpret it as broken line. Now we can focus only on green cells. Marker will be very helpful for us to show what point we are currently into. Now let's read the first part of the data and try to set it as a function. Note that this function has two parts: left and right set of parallel lines. To know what the equation of a linear function is, we need to know the coordinates of at least 2 points. So here I set every point, which will be necessary for our calculation later. We only focus on these points. To make the calculations easier, I add more columns and use the curve-fitting function to read the coefficient values for line function. On Excel, I write down those coefficients for every line. I also add values of altitudes to those coefficients, directly read from image. Now on fresh Plotly instance, we can try to analyze those coefficients. Here I noticed that because that lines are parallel, so coefficient multiplied by x will be the same on Plotly is called with letter M. That almost straight line shows us function how b coefficients change from altitude. Now let's find a function that cuts through both sets of lines and write its coefficients. Let's check out that function with example of 2,000-foot altitude. But firstly, we need also to change our outside temperature into value on x-axis. I'm using marker to read out that value from chart. But it is unnecessary step which only helped me to understand what I got here. Remember not to mix up the plus-minus sign like I did here. Now we write our first function. Our x is 100, our given altitude is 2000 feet, rest can be set as constants. Selecting that part and pressing F9 will fastly change function. Right part of functions are a little bit more complicated. Here m coefficient changes with altitude. But its values also are quite easy to predict. The b coefficient is also not a straight line. But with help of curve fitting, we got its equation. Now we got function which follow 2000 line altitude and temperature given on x-axis. Next step is to interpret outside temperature into x value. I am also using a curve fitting function here to find how x varies with temperature. The m coefficient is close to 1, so can be neglected, while the b coefficient I write for further use. Let's check how it works and if it follows correct lines. The same must be done with other simple axes. The satisfactory result is when I write weight and it changes on graph. Same can be done for other part of chart where weight should be selected. Now do it with speed readout. Simple function for speed depending of weight is a straight line, which we easily retrieve here. Next is to notice that after given value of x as weight into that function we retrieve value of y. This value has to be readout from another function, but firstly we have to swap x and y, because y is now a given value and speed is our query. Now we need to analyze curves on gross weight. Let's get data from it. Here I used the automatic extraction of points from the pen tool. After changing the color to black, the effects are almost satisfactory. We can adjust them by using the adjustment tool and the keys Q for next, E for previous, and arrows to move slightly. Of course, I also delete some of them. The same must be done for at least 3 sets of curves to have data to analyze. At the end of every curve I add another extra point where this curve meets reference line. As you can notice, those curves are some sets of exponential functions. Curve fitting gives us its equation, but it has 3 variables. Let's write them down. They are dependent of value where they meet reference line. So y value of reference line compare with parameter estimates. For better understanding what we got here, let's try to visualize those curves with different parameters. Best tool to do it is tool from demos. After short analysis, we can set parameter C as constant. But parameter A and B are dependent somehow from value on reference line. Super, and this dependency is a straight line with given parameters M and B. Now let's write function. With help of our marker, I will find borders and try to visualize what we got. This new gray line should cover lines as we change value of point where it meets reference line. Here everything seems okay, so we can proceed to next steps. Now I need to write function which from given values 91 and 248 will give us 68. I can select it from table on right and then set constants. Last step is to read out value of gross gradient from Y value. Cleanups as all we got were copied into green cells and all data are below. Now that chart is ready to copy into your datasheet where it will be connected to right values. Thanks for watching and leave some comments or likes if that method helped you.